All right. I left this one up here because it's freaking awesome. That cat has a triangle nose. It's funny. All right. Starting out, 3.5. Isosceles and equilateral triangles. We're going to use these different properties in our proofs and to help us find triangle congruence. So remember, our 5 methods of finding triangles are congruent. Memorize these. They're on the test. You need to know them. The first one is called the base angle theorem. We've mentioned this in class a couple different times, but the official rule on this is if you have an isosceles triangle, then you know the two sides are congruent. Then you also know the two base angles are congruent, namely B and C. Where's my mouse? Here we go. B and C are congruent. So if you've got the two sides, then you've got the two bottoms. Now, if you have a corollary, means we're adding to it. If a triangle is equilateral, then it is equiangular. It's a test hint. Okay, if I give you the fact that it's equilateral, you may have to get some information about it to get the angles right. Okay, so I want you to know both of these work both ways. So if I give you both sides, then the angles work. If I give you both angles, then you have both sides. Same with the equilateral. If I give you all three angles, then you know all three sides are congruent. We don't necessarily know how big they are. They could be huge or they could be little. But we do know that they are equal to each other. So be careful with that. It can get tricky quick. All right. So we have here 65x, but we know it's an isosceles triangle. I can see the two sides are congruent. So that means I know that the two base angles are congruent as well, which gives me the fact that x equals 65. Because the sides are the same, the angles have to also be the same. And the reason for it is base angle theorem. So converse, here we go. See this? I told you. Works both ways. If two angles of a triangle are congruent, then the sides opposite them are also congruent. So if B equals C, then AB equals AC. And the corollary to the equilateral triangle one was if the angles are the same, then it's equilateral. We don't necessarily know how big they are, we just know that they are equal to each other. So here I give you the base angles are the same. So we crisscross and we know that the two sides are the same. So I say that 7x plus 5 equals 13 minus x, and I pull off some algebra. Let's see, addition property of equality, subtraction property of equality, division property of equality. Oh, geez, where am I? Here we go. Look familiar? Yep. But that's a lot. Fill in your notes. Now, if we talked about which angle's 42, how big are these two bottom angles here? If this one's 42, these two have to be the same in an isosceles triangle. So let's see, 42, that means this one's got to be, the total has to be 180 minus 42, which should be 138. And then if we split 138 in half, it should be 69. Is that 69? Yeah, 69. So each of these angles is going to be 69 degrees, and this one's going to be 42. I just did that in my head. So if this one is 42, then that means these other two angles have to be something else. All right, let me pull up my handy dandy pen. Let me go back up one here. So this one's 42. These two are equal to each other, all right? That was terrible. Okay. Now it's doing that again. What's going on here? Pen. There we go. Isn't working so good, is it? All right. Oh, I'll figure this out eventually, I promise. So if I have 42 here, just like it won't ever pick up the pen. Try and flip this around. Okay, so now it's in tablet mode. Sweet. So that means that this angle has to be the same as this angle. All right. And if that's true, then it has to be 180 degrees minus 42 gives me 138. And now if I divide that by 2, I get 69 degrees. So this one's 69, and this one's 69. So now If this one's 42, then I know that both of these have to be 42. So this one's 42 as well. Now I got to find out what this top angle is. Well, if they all add to 180 degrees, then I have to subtract 84 degrees for these two bottom angles. And I end up with 96 degrees. So this angle up here is 96 degrees. So now, here, I'm told that it's isosceles. I'm told that much. And what I gather from that is that means that the base angles are the same. Base angles theorem. So that means that this one is 66 as well. And if they're both 66, then I do 180 minus, what is this, 132? Yeah, that's right. 7, carry the 10, 8, 48. So that means this angle up here is 48 degrees. All right, not so bad. So here, we go on to the next problem. Okay, can you find the other two angles of an isosceles triangle if you know one of the angles? This is an essential question. Please answer it on your own. Pause the video if you need time. I'm going on. So find x. Oh, geez. X in the picture is right up here. It's the top angle. I know the exterior angle here is 120. I need to know the interior angle. And since they form a linear pair, I can now use linear pair. That's my reason. That's why y plus 120 equals 80. Now, if I go on, oh, what happened here? Push the wrong button. All right, linear pair. Then I can do subtraction property of equality, and I can say y equals 60. And if y equals 60, then I use the triangle sum theorem. X plus 60 equals 80. X plus 120 combine like terms. And then I subtract 120 over, and I get subtraction property of equality. Regardless, I find out that x equals 60. I just took the linear pair here to solve for y. I used isosceles triangle information here to say this is also y. And then I used the triangle sum theorem to solve for x. Ooh, parallel lines and everything. Look at this. Find x. Interesting. So, because the base sides are the same, we know these two angles are the same. We're using isosceles triangles to show that this angle is congruent to this angle. What that does for me, since they're parallel, it sets up an example of alternate interior angles. So I can say that this angle here and this angle here are the same. And this angle here, well, let's see, this angle and this angle form a Z. This angle and this angle form a backward Z. So they're equal to each other. Regardless, all four of them are equal to each other. So I use that to set up my proof. And I say 2x equals 90x. My reason for that? Base angles and the alternate interior angles theorem. Again, it's isosceles. So since it's isosceles, I can use that information to say that these two angles are congruent. I then use alternate interior angles to show that, let's change color on that one, shall we? Why is that working like it's supposed to? Alright. I'll use a different color. So these two angles are the same from alternate interior angles. And these two angles are the same from alternate interior angles. Well, if I go from green to green, well, green and red are the same. So then green and red are the same up here. Regardless of how you want to do it, all you need to know is that they're equal. And then we use a little bit of algebra to solve. And we say x equals 30 based on the division property of equality. So that's my reasoning. Oh, this is sweet. Given AB is congruent to AE, name an isosceles triangle and its two congruent angles. So if I say that AB is congruent to AE, I have to find a congruent triangle. So I would add that in there. There's my two. The red part is the legs of the triangle. The base is right there, BE. So it says name an isosceles triangle. Says triangle ABE is isosceles, and its two congruent angles. Well, the two angles looks like it's going to be angle B and angle E, but we want to be more specific. Notice how B and E are in the middle, but I want them to be more specific. So I say angle ABE, or I say ABC, and angle ABE are my two angles. All right. Any questions? Don't have time for questions. Got to move on. So in the video, here we go. Given angle V is congruent to angle Y, name an isosceles triangle and its two legs. Wow. So angle V and angle Y. I label those on my diagram, and that helps me see that the big white triangle is actually isosceles. So if I look right here, I've got this big whole white space has the same congruent base angles. So I would say right here, I'd say SVY is my triangle. Its two legs are going to be SV, oh geez, and SY. So I look at the two opposite the angles, and I get SV and SY. And that's how we use isosceles triangles in proofs. Worksheet 3.5. Oh, I like this. This is awesome. 1 through 20. The rest are extra credit. Yeah, that's cool. So now we're going to do some additional kind of discussion about triangles and their angle measures. So what happens here is I notice I've got 8 inches, 7 inches, and 13 inches. Well, if this is the case, which is the largest angle? What happens is we notice what happens, you look at the biggest side, it's 13 inches, right? And the biggest angle is the angle opposite the biggest side. So the largest angle here is angle A, because it's the angle opposite the largest side. Okay? Now the smallest angle, if that's true, the largest angle is across from the largest side, then the smallest angle is the one across from the smallest side. So 7 inches is the smallest side. So we look for the angle across from the 7, or opposite the 7, and we see that it's angle B. So we say our answer is angle B. So here, find the missing angle. So we have 32, 38. Can I find out R? Well, that's just R plus 32 plus 38 equals 180. 32 and 38 combine to give us 60, 70, looks like, 70. So we subtract 70, and that gives us R equals 110. So this side up here equals 110. We can check our answer. We can say 110 plus 32 plus 38 should equal 180. And it indeed does. So we can use our triangle sum theorem to solve for missing angles. All right. Well, let's see. Now, at this point, it says, what is the longest side of this triangle? Well, I find, again, the biggest angle, and the side opposite the biggest angle is also the biggest side. So P, that's a terrible P, PQ segment, this is the longest side because it's across from the biggest angle. See how that works? All right, now, what is the shortest side? Well, if it worked for the biggest angle, we also have to think it will work for the smallest. So we take 32 as the smallest angle. The side opposite of it is RQ. There we go. That's it. That's your summary. Go ahead and fill out your summary, fill out your notes, and make sure you get your homework done. 3.5. Remember, extra credit. I'm going to go back to that slide so you guys can see the extra credit. Do problems 1 through 20. The rest are extra credit. And don't forget to do the review worksheet. Don't forget to do your review worksheet. It's good to do it for the test. The test